Hello and welcome to Amit's Tech Sessions. My name is Amit and I'm a software architect. In this session, I will explain event-driven architecture and will cover fundamentals of event-driven architecture along with some of the options around how you can actually build an event-driven architecture on AWS. So first, let's understand what is an event-driven architecture. An event-driven architecture is a pattern which allows loose coupling between two or more systems or applications or microservices. This pattern leverages events to trigger and communicate between decoupled microservices. And what are events? Events are the representation of a change in a system. For example, if you are dealing with an e-commerce application, example of an event could be a new product added to cart or an order is placed. These are some type of examples of events. In an event-driven architecture, there are three key components. First is event producers. Event producers are the systems who actually publish the events. They are upstream system responsible for triggering the event in case of a change. Such example could be a front-end application, microservices, IoT devices, AWS services, some SaaS applications, etc. The second key component in an event-driven architecture is event broker. So event broker are the mediators between the producer and the consumer. They make sure that the right event is going to the right consumer. The third component of an event-driven architecture is event consumer. Event consumers are downstream systems who receive the event and then act based on that event type or the payload. Event consumer may have different responsibilities such as updating the database, running a different workflow, or performing any analysis, etc. There are various benefits of event-driven architecture. I have highlighted some of them here in this slide. So the first benefit is that in an event-driven architecture, systems can scale and fail independently. In event-driven architecture, we have decoupled services. So by decoupling those services, they are only aware of the event router. They're not aware of each other. So event producer does not know who is event consumer. So that means if one service has a failure, the rest services will still keep running. And event router acts as an elastic buffer that will accommodate the surges in the workloads. Event router can sometimes hold the data as well. The second benefit is development velocity. So you no longer need to write custom code to poll, filter, and route the events. The event router will automatically filter and push the events to the consumers. And router also removes the need for heavy coordination between producer and consumer services, which actually speeds up our development process. Another benefit of event-driven architecture is audit with ease. So an event router acts as a centralized location to audit your application and define the policies. And these policies can restrict who can publish and subscribe to a router and control which users can and resources have permission to access your data. You can also encrypt your events both in transit and at rest. Last but not the least benefit of event-driven architecture is cost reduction or cost optimization. Since event-driven architecture are push-based, so everything happens on demand. So this way you are not paying for continuous polling to check for an event. This means that less network bandwidth consumption, less CPU utilization, less idle fleet capacity, and also less TLS handshake. This helps you to achieve a cost reduction. There are various use cases for using event-driven architecture. Some of them are highlighted here. So if you have, let's say, systems which are running on different stacks, you can use an event-driven architecture to share the information between those systems without coupling. The event router establishes indirection and interoperability among those systems so they can exchange messages and data while also remaining agnostic. You can use event-driven architecture for parallel processing. with fan out. So let's say if you have a lot of systems that need to operate in response to an event, that is where you can use this event-driven architecture to fan out the event without having to write any custom code to push to each consumer. Fan out means that you have one event producer and you will have multiple event consumers which will receive the same event from event producer. You can also use an event-driven architecture to alert in case of any system anomalies. Rather than continuously checking on your resources, you can use this event-driven architecture to monitor and receive alerts on those anomalies or any changes or any updates. Another use case for using event-driven architecture is microservices communication. So you can deploy, build, and scale microservices independently with event-driven architecture in a microservice-based applications. An example could be an e-commerce application, as I previously mentioned. To implement an event-driven architecture on AWS, you can use various AWS services. Some of the common services are Amazon SQS or Simple Queue Service, AWS Lambda, Amazon SNS or Simple Notification Service, AWS API Gateway, AWS Step Functions, Amazon Event Bridge, etc. And if you want to process a large amount of data or large chunk of data in a streaming format in your event-driven architecture, then there are two services which are very powerful. One is Amazon Kinesis Data Streams, and second one is Amazon Managed Streaming for Apache Kafka or MSK. I'll explain each service in one or two lines. So first one is SQS. Right? SQS is a fully managed message queue service that enables decoupled communication between components in an event-driven system. It allows components to asynchronously send and receive messages or events through the queues, which ensures the reliable and scalable message delivery. AWS Lambda is a serverless computing service that allows you to run code without provisioning or managing servers. Lambda functions can be triggered by events from various sources such as SNS, SQS, API Gateway, and more. Lambda functions can process events, perform the business logic, and also interact with other AWS services, which makes them a key component in an event-driven architecture. SNS or Simple Notification Service is a publish-subscribe messaging service that facilitates the broadcasting of messages or events to multiple subscribers simultaneously. Amazon API Gateway is a fully managed service that makes it easy to create, publish, and manage APIs for applications. Amazon Step Functions is a serverless workflow service that enables you to coordinate and orchestrate multiple AWS services and custom actions in a visual workflow. It provides a way to define and execute complex state machine workflows, allowing you to design and manage event-driven workflows with ease. EventBridge is a serverless service that uses events to connect application components and allows you to build scalable event-driven applications. Amazon Kinesis Data Stream is a serverless streaming data service that makes it easy to capture, process, and store data streams at any scale. Amazon Managed Streaming for Apache Kafka or Amazon MSK is a fully managed service that enables you to build and run applications that uses Apache Kafka to process the streaming data. Amazon MSK provides the control plane operations such as creating and updating and deleting the clusters. There are different common patterns as part of event-driven architecture. One of them is point-to-point messaging. Point-to-point messaging is a pattern in which producer send the message which is typically intended for a single consumer. So point-to-point messaging often uses messaging queues as its event broker. And queues are messaging channels that allow asynchronous communication between a sender and a receiver. In microservices application, asynchronous point-to-point messaging between microservices is also referred to as dump pipes. In this reference architecture, on the slide, you have AWS Lambda as an event producer, Amazon SQS as an event broker, and AWS Lambda as an event consumer. So you have one event producer and one event consumer. This is asynchronous point-to-point communication between two microservices. You can also replace these AWS Lambdas with Amazon EC2 instances or any container instances running on Amazon ECS or EKS. In a typical microservices architecture, these AWS Lambda, Amazon EC2, etc. are running a microservices. So SQS is one of the services to achieve point-to-point messaging. And there is one more AWS service called Amazon MQ or Amazon Message Queue, which can also be leveraged for point-to-point communication. Another pattern in event-driven architecture is PubSub messaging or publish-subscribe messaging. PubSub messaging is a mechanism in which producers send the same message to many consumers, whereas point-to-point messaging usually sends messages to just one consumer. So PubSub messaging allows you to broadcast messages and send a copy of each consumer. The event broker in these models is frequently an event router. This diagram provides a reference architecture of PubSub messaging implementation on AWS. You have event producer as either AWS Lambda or Amazon EC2 or any other AWS service which can deploy a component or a microservice. The event producer publishes an event to Amazon SNS topic. Amazon SNS topic is subscribed to multiple Amazon SQS queues. As soon as the event is published to Amazon SNS topic, event is routed to all those multiple SQS queues. Each SQS queue is subscribed to its own AWS Lambda function. All these Lambda functions are the event consumers. Instead of Lambda functions, you can also have Amazon EC2 or other services as event consumers. This is a type of fan-out pattern where one publisher is sending event and multiple subscribers are receiving the same event data. At SNS topic, you can also implement filtering. Filtering allows you to send only a specific type of event to specific queues. As an example, if one event consumer Lambda is only interested in order created event, then its SQS queue can subscribe to SNS topic with a filter condition of event type order created. This reference architecture uses SNS as event router. Same reference architecture can also be achieved by using Amazon Event Bridge in place of Amazon SNS. Another pattern in event-driven architecture is event streaming. So in contrast to event routers, though comparable to queues, streams typically require consumers to poll for new events. So consumers maintain their unique filtering logic to determine which events they want to consume while tracking their position in the stream. Event streams are continuous flow of events which may be processed individually or together over a period of time. The diagram here provides a reference architecture of event streaming pattern implementation on AWS. You have event producer as either AWS Lambda or Amazon EC2 or any other AWS service which can deploy a microservice. The event producer publishes an event to Amazon Kinesis data streams. Event consumers, which are AWS Lambda functions in this architecture, they receive the events from the Kinesis data stream. In place of Kinesis data stream, you can also leverage Amazon Managed Service for Apache Kafka or MSK. In place of AWS Lambda, you can also have different AWS services as consumers of the streams. That's all I have for this video. I hope this was useful. If you would like to connect with me on LinkedIn or Medium, there are QR codes up on the screen. Thank you.